Okay, so now it's time for problem number 3. So let's try and figure out what this is all about. Implement an algorithm which computes the inverse of a matrix with the help of the Neumann series, example 1 on page 199 and theorem 1 on page 198 can be used as inspiration. Okay, this seems to suggest we are not having pseudocode here, we just need to wing it a little bit. Let's see what else. Use your implementation to compute the inverse of the matrices B blah 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 and C blah 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 with 50 summons and 20 digits of precision. Last but not least, output B multiplied by B inverse and comment on the result. Hint 1, you can write your own procedure for computing powers of matrices or use the method matrix power A, K in the linear algebra package. Blah, linear algebra package hides all the treasures, such as identity matrix, hint 3, assumption 1, so that's infinity norm of A, I guess should be less than 1. Okay, so let's get started on this thing. So, as always, a restart. It's always nice to do. We're gonna use the linear algebra package, so we're gonna have width, so we can play around with all the stuff from that package. And we don't want to see all this output. I'm just gonna do this. And let's see, we needed to have 20 digits of something here. I think it said. Why did I read that? Oh, here. Okay. That's digits equal to 20. And we need 50 summons, so that's probably gonna have something like n equal to 50 somewhere. Okay. And let's see, we need some matrices, B and C. And if I remember correctly, we can more or less just initialize these with this input. Let's just make sure. Yep, so that looks fine. And we need a C matrix also. It's this one here. Okay. Like that. I don't want to look at all this output, so we're just gonna do it like this and this, this. That will be a little bit more easy to work with. And then we need to write a procedure for computing the inverse using the Neumann series. So I guess it should be called Neumann inverse or something like that. It's a procedure. We need to take as input the matrix we want to find the inverse of. Let's call it M for matrix. And the number of terms in the series that we want to include. Like this. And let's see if I remember correctly. We need to do this A matrix. This is actually A, that's going to be summation of A to the power of 1, 2, 3, 4 up to N. A is going to be the identity matrix minus M. And the identity matrix, you can get that from the linear algebra package. It's probably going to have some dimension input. So we should get that probably from the M matrix. Then the code will be a little bit more generic, I think. Could be something like this. We need a local for this one. And let me see what else. Probably also need a local to store the result that we're gonna create. Could just initialize this to be a zero matrix. It could look like this. Probably also gonna need some sizes, row dimension of M, row, comma, column probably. I should look in the help for this, but I'm kind of winging it from memory. Okay, let's see. So if the norm of this A is too big, then we can't hope that we will convert, so we should test for that somehow. Something like this, and then we need to infinity, something like that. As an equal 1.0, then and if let's just return the current one, that would probably be the zero matrix, and then it might be nice just to print something out. Like this. And let's see. So matrix power was the other hint of A, comma, what do we need? We need to add up matrix power from A equals K equals to, see, 0, 1, 2, 3, 4. So might be able to use this one. If K, then we need to specify from K equals 0 to N. That should do the trick, I think. It's a bit of a cheat to use these kind of inbuilds. I could just have written a for loop here as well, just going all the loops and adding up these matrix power terms. So I'm going to return M inverse like this. Let's try and make the code pretty. Okay, let's see if it works. So far so good. Then let's try and use it. So we should use it on B Neumann inverse of B. So let's say this is B inverse. I'm gonna assign to that, and we need N as input. Let's see if it runs. It was not quite evaluated. Let's try one more time. Does still not work. That's a misspelling. That's the reason for that. Then we have some other issue. Row dimension M, column dimension M. Let's just see how far we get down here. Okay. Zero matrix, we get something wrong here. oh man, matrix. That looks better. Spelling right really helps a lot. Okay, then we should print out what B times B inverse is, like this. What went wrong here? Oh, that's because it's dot we're gonna need. Okay, and let's see. So this is actually pretty close to the identity matrix, and we're running with precision of 20 digits, and if we look at the results here, we can actually see that it's within 20 digits precision, so that actually makes sense. So that's actually the thing we need to comment on. So this is this part. Then we need to do the same thing for the C matrix. Just copy pasting. C inverse, Neumann inverse, C multiplied by C inverse. Let's see what happens. Whoops, it could not convert. Matrix norm not less than 1. Let's see, oh, that might make sense. It has this big number here. That's probably what's gonna fool it up. Okay, so basically just need to comment on it. So let's just format this pretty so it's more readable for whoever's gonna read this. There we go. That's it.